Okay, the recording has started now. Let me switch to the Google Chrome page so that we can see the website of the competition back again. So,
Only me here.
yes?
I said it's only me here. Everybody is not here.
Okay, they can watch the recording when they are back, okay? But today's meeting was really urgent, and I told you the meeting time yesterday, so they should have been ready for so. Anyway, let's go now. I just wanted to ask everyone if you tried to go here and practice a little bit, program your robot and try some stuff or not.
Still no.
You're too late, guys. You have to explore and try to figure out how to program the robot and explore yourself. That's fine, Yani. I mean, we can still do something here. Okay. That's already still loading. Okay. Okay. Well, okay, how can I resize this?
Besides what?
The coding part, because whether this is large and this is small, or this is large and that's small. That's okay, we can switch between them. So let this one or the environment be loading, but now let's talk about the program itself. So as you see here, it's on like Scratch, exactly like Scratch, like you have on start, what should the robot do? So there are the blocks responsible for moving the motor, okay? And here are the sensors, okay? Loops, if you would like to repeat something, logic, okay? Like this looks like the if statement in programming, and also the functions here. So let's start with the motors block. So again, in the code itself, we have this part that is on start. Let me get this one here. Yeah, we can see it here. So I'll use them side by side like this. So for example, here's our robot. And what should the robot do on start? I should move a medium motor or a large motor or two motors together to get the whole body of the robot move. What do you think, Zaid, I should do?
What, teacher?
What do you think I should use? Which block I should use if I want to move the whole robot?
If we want to move the robot, we'll
Yes.
use the tank motor.
Yes, but it's not here. It's not defined as tank motor. So, yeah, you mean this one? Yeah,
You
tank.
use on.
Tank motors. Yes.
Yes.
Tank is like moving the robot like a tank. That does this tank moves like two wheels together at the same time, or I can change the power of one of the motors to be different from another. In case you would like your motor or your robot to go forward, you have to set the two motors at the same power, right? And that one for how many how much, like milliseconds or rotations or degrees or seconds. Okay. So what does a rotation mean? Do you have you got any idea about what do you mean by one rotation? Yes.
Yes. I'll draw it so I can explain.
It's okay.
For example, this is the circle, the wheel.
Yeah.
Okay, when it starts from here, from this point, it starts from here, and it turns like this. When it comes back to this point, this is a full rotation.
That's perfect. Amazing, Zaid, mashallah. So that's a full rotation. Okay, how many degrees are in one rotation? So
100, no, not 180, it's 360.
360, yes, perfect. So there are 360 degrees in one rotation, because the one rotation of a motor actually is like rotating a circle, a whole circle. So the circle is 360 degrees. Half a rotation is 180. Okay, quarter of the rotation is like 45 degrees. So that's how it works. You got some degrees. You can chop down the speed or the distance into degrees or into rotations. Or sometimes we use seconds, okay? Seconds, because actually sometimes if the robot is not able to achieve these number of rotations, you'll get stalling. You know, stalling means that the robot will stop and it will stop also executing any other code. Like it gets stuck, okay? So for example, if I ask the robot to move like 2 rotations, and these 2 rotations in the middle, like one and a half rotation, he got stuck in a wall. So the robot will not be able to do anything else because it couldn't achieve the goal, and it's not gonna move to the next block, okay? But if you give it like seconds, even if it hits a wall, so whatever the number of seconds that passes, it will go to the next block, even if something wrong happened. So in some situations we use seconds, other situations we use rotations. But if you need something really accurate, it will be degrees, and you should measure this first. In real life, I would ask you to put the robot on the start point and give reset to the 2 motors, or like to make them read 0, and then move the robot by hand until your target point and see how many degrees did the robot measure. So I use the robot itself as a measurement tool. You got my idea? But here in the virtual environment, I cannot do this. So you have to give it try. It will be depending on try and error. So you will get a specific number of degrees and see if your robot will reach the target or not. If not, you can increase them or decrease them depending on what happens in the situation. So now, for example, I would like to move the motor like 360 degrees. Okay, so I put my number here, 360. Okay, tank motors A and B. Each motor is running on 50% of its power. So let's see the result of this one. Okay, if I click start now, let me close this screen. Okay, so this is what happens. The robot goes for like 360 degrees and then it stopped, which is like 1 rotation. So it didn't go anywhere, right?
Yeah.
So in that case, I would like to increase them. So instead of increasing them, yeah, I've expanded this now.
We will change from degrees to seconds or rotations.
Yeah, that's perfect. Let's go with the rotations, because actually while it's like we are planning our mission now. I want the robot to come to this area, for example. I don't know how much it is. So I will start inaccurate first. So I'll give like an arbitrary number or a random number. Yeah, like 5 rotations, for example. 5 rotations, and see where does it where far will it go. Like 5 rotations. I had to reset first. Reset. So I put my robot here and I'll start the 5 rotations. I guess the 5 rotations will be too much. It might hit the wall at the back. Yeah.
It's stuck.
Yeah.
So what is this +5, +5, -7? What are these?
Well, I guess it's just counting the seconds here. I guess it's something has a relationship with this. Actually, this online platform, they didn't give us good instructions about what is happening here on the screen. Even the Saudi trainer on the YouTube channel that I showed you, she didn't mention this part. So that's why we are just exploring yet, because there are no good instructions here or there. We have to explore everything ourselves. Actually, to know what should you do in this table, you should have had the real table already. So now, for example, I don't know what should we do with these cars here. And looks like these competition, these things were from another competition before, last year or last 2 years. Okay.
This is an AV3 robot, right?
Yeah, it's the same one as I showed you in the PowerPoint presentation. This is why I started with the PowerPoint first. So, yes, these are all the information you have about your robot. So let's close this one and go back. This 32. Okay, this is the counter of how many seconds. Maybe that's the power. Okay. Distance, there's nothing inside. The gyro angle. That's a color sensor. Reflected is like 100%, like because it's standing on white. Okay. And that's the front color, another color sensor that sees something on the front, but there's nothing on the front. Okay, that's good. So far, so good. Let's go explore more. So now I started, I asked the motor to start running for 5 rotations, but I see that the 5 rotations took the robot so far. So I might make it 4 and then
We need one.
Yeah, I'll erase one of them. So I'll make it like 4. Let's reset. 4 again. Number 4.
Teacher, can it's you can put like, for example, half rotation.
Yes, sure. 0.5. Or turn this into degrees, like 180 degrees. I see that the robot is not stuck in the wall, right? So 4 rotations are fine. So what if I want now to turn right? I should take also tank motors. So after moving these 4 rotations, I should turn right. How should I turn right? Like if I turn in...
Put degrees.
Yes,
but 90 degrees.
Yeah, it's okay. So 90 degrees, it's okay. But again, the idea is that the 2 motors now are equal, right? So if I run this block, the robot will move forward again. I don't want my robot to move forward. So I have 2 options now. If I make this one like 0.
0, yeah, 0.
So 0 in the left wheel or the left motor, 0, and right motor will be 50. Imagine the movement of the robot and tell me whether it's gonna turn to the right or to the left.
To the right or to the left?
Yes.
No, teacher, I think like this, it will go to the left.
Yeah, it's gonna go to the left. Why? Because the left motor is stopped and the right motor is moving forward. So if the right motor moving forward and the left motor is stopped, so the robot will turn left. Can you see this? Okay, let me reset and turn these blocks back, these 2 blocks. So it will go the 4 rotations, and after the 4 rotations, it's gonna go like, okay, I said 0 degrees, 180 degrees, for example.
Oh, teacher,
It's
we
gonna
need
continue.
only 90.
Yeah, let me reset first. Let me try. I'm just exploring, showing you an example. Okay, and already we don't want the robot to move to the left side. So looks like that's the left side of the robot or right side. The motor.
This is the right.
No, wait, the robot itself is flipped. So it starts at the 0 position like flipped. You see that the robot is moving by its back. You see? That's why that causes a problem. Yeah, it's flipped. That's okay. All right. Now we know which is right and which is left. So actually, I should go with this left one. So like 50%, and the other motor will be 0%. Let me try it now. So the robot will move forward like for 4 rotations and then turn the left side for 180 degrees, which is like half a rotation. But if you notice that one of the 2 motors is not running, it's just stopping. So the robot will move around this axis. So this motor will stay in the same place, but the other motor will go the other side. So it's gonna draw half a circle here. What happens if I make the 2 motors run against each other? So like one of them is 50%, the other one is like minus 50%. What should happen in this case? So the robot should turn around its axis, like if you put your finger in the middle, so the robot will turn itself around your finger. You see now the result? It's different one, right?
Mm.
And as you can see, the 180 degrees are not enough to turn the robot all the way, like 90 degrees.
It's wrong, teacher. We need only 90 degrees to go like this to the right or left.
90 degrees, like half a rotation of the motors?
No, I mean 90 degrees.
90 degrees, yeah, Zaid, if we are using the gyro sensor, but we are not using the gyro sensor here. We are depending on the movement of the two motors. But you will have no idea what will this 180 degrees take you to which angle. Actually, that's not the correct thing. It's better to use the gyro. The gyro will give you a specific value of the angle. But depending on the how many rotations or how many degrees of the two wheels are needed to turn you into 90 degrees, so you have to calculate this, and again, it's a matter of try and error. So now I'll use something more than 180. Let's say 200. Yeah, let's try with 200 and see, will this turn the robot into 90 degrees or not? So you know your mistake now, Zaid. You have been mixing between the degrees of the wheels and the degrees of the compass, right?
Yes.
So 200 are still not enough. Okay. So let's start with
215.
I tried 220. I guess this would be enough. Okay. So I now will know now if I want my robot to turn like 90 degrees, how many degrees of rotations I would need. You see? I guess 220.
200.
215. 210 maybe will be all right. Because I guess now there is this still a difference, right? It's not fully 90 degrees. It went more. So let's try 210 and see what happens. Or maybe I'm going to use the gyro, right?
Right.
Okay, so now 110 is perfect, I guess, right? 210 is perfect. So every time you need your robot to move or turn 90 degrees, you should turn the wheels into 210 degrees. Easy? So now actually I don't want this. I want the robot to turn to the other side so that I'll go to the machines. So I'll flip the movement to let it turn right instead of turning left. So the robot is going to move forward for 4 rotations, and then it's going to move right 90 degrees. Then I'll ask the robot to move forward again. So I'll go tank motors, A and B, also for a specific number of rotations. And let's say for other 3 rotations and see the result. Easy? That's how you can build your program. Try one by one until you achieve your target goal. So it's going to turn and take this car, which is the green one, push it all the way until it stops. So where should I put this car?
I don't know. In the P sign.
Me too. I have no idea also. Maybe to the parking side.
Yeah.
Okay, maybe it's gonna be taken to like this car here. Maybe we have to take this car and put it here in the red square. So I need the robot to move forward more. Let's see how much distance is needed. Like 3 more rotations, right? So now, and instead of 3 rotations, I'll take it 6 rotations forward. So let's try this out. So we will take the green car and move it all the way until we reach this area. So that was too much, right?
Yeah, try 4.5.
I guess this would be like, you know, like 6. Let it be 5. Okay. Because I guess if you take this robot backward, you'll take 1 rotation to go backward to this area. So I'll try with 5 rotations. Okay. Let me have a look. Well, it stopped here, but because it was running on 50% power, that was too much. So that when it stops, the car continues to slide. Okay. So I would actually how to push this car to this square. It's not clear for me because if I keep pushing, if the robot turns right now and goes towards this red square,
I know what to do.
it will not take the car, right?
Yeah.
So let me
I know
say,
what to do. This.
let me take it 4.5 rotations. 4.5 rotations.
Yes,
And after these 4.5 rotations, I'll move forward for 1 rotation or less than 1 rotation in a slow
but you
speed.
need to make the tank motor for the third block. You need to make it lower so the car doesn't slide, isn't it?
Let me try 10%. 10%. Okay. Now let's go back again from the beginning. Okay, let me have a good look. So it's pushing. Now it's stopped and it's gonna continue at a slow speed. Have you seen this? I need to move a little bit forward. Okay, so that when it turns right, it will be opposite to this one. Because it turns right now, it will be opposite to this area. Do you agree with me?
Yes, yes. You need the car 0.25 rotation.
No need for this. I'll just make this 0.5 rotations at 10%. I'll make it 1 rotation. So that, again, we will be moving on a slow speed so that it will not miss the car. It's not gonna miss the car this time, I'm sure of it. Okay. But again, using this slow speed, of course, is a bad plan because it will waste more time. Time is very important. There is a counter here that counts the time. But it's fine now because we are still trying to figure things out. So now I have to move to the left side, right? 90 degrees to the left. So now what I knew before that 210 degrees will take me 90 degrees, right? So I'll take this similar block. So is there a way to duplicate? Yes, I duplicate this block and I flip these. So it will be 50% here and minus 50% here. Let's try this one out. So after turning, I need to move forward. Oh, I would like to duplicate this one. I'll move forward again at like 10%. Again, let's move slowly first at the beginning. 10%, and here also other 10% for like 1 rotation. I guess 1 rotation will be enough. Can I try this one? Let's see. Will this take the car to the parking area or not? You see, it hits this car out of the place now, which is something incorrect, of course. Why did this happen, Zaid? Give me the reason.
Teacher?
Yeah, give me the reason. Why did the robot miss the car? Have you seen this?
Because no, actually, I was fixing something.
Okay, I'll show it to you back. I'll start back. Just keep your eye on the robot. So now it took the car. Yes. And now it stops. So it misses the car, then goes slowly. It will pick the car back again. But what happens here when it tries to turn? It will miss the car, right?
Yes.
Why does this happen? What do you think?
I think because the car, like, it moved very fast.
You mean the robot?
Yes, yes.
Yeah,
Sorry, not the car, the robot.
it turned it super fast. So actually, I should, when the robot is turning, I should use a very slow speed. So I'll make this one like 10% again and minus 10%. Minus 10%. So let's see the effect of this change now. Will it miss the car too? But again, using slow speed will count more time here, right? And what you need actually during the competition is to make as many tasks or missions as you can in the shortest time possible. So now let's see the effect of this slow turn. And again, although we are turning slowly and still missing the car. That shouldn't happen, actually. In real life, this shouldn't happen because turning at 10% is really smooth. Let's make it 5.
This program is not accurate at all. It's trash for real. Like, you teacher, you put 210 degrees, it will the 210 degrees it will move 90 degrees. Like, and also the robot is flipped. The one who is participating, his mind will be
Zaid, listen, we are not using the gyro here. So I'm not talking about 90 degrees of a compass. Again, I'm talking about 90 degrees of a compass using the degrees of rotations of motors, okay? So you have to find the relationship until you use the gyro. If you're using the gyro, yes, you have to put 90 degrees. So it's turning at 5% and still the car is sliding.
And you will have to put 1%.
Not 1%. This will consume too much time. And now you see what happens. It looks like the robot was about to move on the car.
So stupid.
Yeah, that's really stupid. But again, we can figure out a solution to this one.
I don't think they will ask us to make parking.
Let's slow this down to, as you see, as you say, 2%. 2%. And
teacher, you're doing the wrong one.
I'm trying to figure it. No, that's the last turn.
Yeah. Sorry. My bad.
No problem. So I'm just giving you an example, but you if you keep trying, Zaid, you will do it. Okay. I'm just giving you a very simple example of how the programming takes place.
So, teacher, if you want to switch to gyro, how will you change?
Yeah, I'll show it to you now. Now you see we're turning very slowly at 1% and still the car is sliding. How come?
Maybe we'll have to put 0.001%.
The robot takes too much time to get to to the 90 degrees. That's really bad. I didn't expect this, by the way. How will the car slide like this? It's successful anyway, as you see, but the robot is pushing the car by the wheel.
Well, by the end, it still pushes it, so it's considered.
Anyway, so now if I want to use the gyro, you go to the sensors bar here, pause until touch one pressed, like touch button, touch one is pressed. And also this is for the color sensor, pause until color sensor one detected like blue, and so on. Where is the gyro? A gyro sensor is at pause until gyro is rotated like how many degrees, and reset the gyro.
Right.
So my advice is by the beginning of the program, you have to reset the gyro, because actually you don't know what value will be stored in the gyro. So you have to clear the gyro value. Okay. And then I'll go to gyro one angle. I'll try this one. But again, here, tank motors, until we get to, can I insert it here? No, I can't. So I have to use a function that will take this part inside it. So loops, not the loops. Yeah, so while gyro, like this. While gyro is one, do what? I should stop, right? But it's not working here with this. Let me try something. So yeah, do if gyro one angle is at what, you have to stop, right? Why isn't this one coming here? Okay, let's say there should be something here that will take this block inside it.
Maybe you're not supposed to put it with while or if.
Now it should be. As you can see, how to know that something should work or not, because this part here is suitable to this area here, right? So they should be put together. I don't know why don't they work together like this? It refuses to connect. And of course, this is not the correct place.
I mean, why not put it here? Where's
So you see this one works fine. If touch one is pressed, do something, right? What if gyro one angle? Maybe because we have no angle, no gyro, right?
maybe?
Maybe this robot has no gyro. So let me go back to the robot. Gyro is at 3, okay? Let's try. Wallahi, I don't know why does this happen.
It's carbon.
No, there should be a reason behind this. We have to discover. So let's go gyro 1, pause until gyro 1 rotated how many degrees. So let me try this one. And it says pause until it rotated like 90 degrees. Let's try and see the effect of this one.
But teacher, at 90 degrees, it means it will go to the right, not to the left. If it wants to the left or right, negative 90
Yeah.
degrees.
See, he says incorrect sensor type at port number 1. So what is here on port number 1?
How you see the port things?
That's front color, that's down color, 2 color sensors. And the gyro angle is at 2, I guess, right? 2. Let's try. Yes. I don't understand what's the problem here.
Yes, this one. I was about to ask 3.
Yeah, this
The
one
rest.
says it's on 3, but in the screen here, it shows that the gyro is at 2. Okay? Or that's
How
3.
you know it's
3? We are not on port number 1. Ah, here, that's the problem. Okay, I got it. We in the reset, we said reset port number 1, and the gyro was not on number 1. So now let's try this code and see what happens. We have 3 minutes to finish this meeting, and I hope it works fine. But pause until gyro reaches these degrees is not
go to the
suitable.
right.
Yeah. It's gonna wait until the gyro goes to this degree. What will let the gyro go to this degree? You see now it didn't turn. It will keep moving. Right?
Until what?
Yes, because until gyro 3 is rotated 90 degrees, and then it will move forward these rotations. So
How it will go 90 degrees?
yeah, let me go back and try. Where's the gyro angle?
Maybe it was
If we should use an if statement now.
if or while.
No, if. So I should say if gyro 3 angle. It's not working again. It should be here. If the gyro 3 angle is like equal to 90 degrees, I should do stop the motors, right? It's not working. Why isn't it working? That's the problem. And again, everything else,
Maybe
color sensor is working. Color sensor and touch sensors are working.
Maybe you're not allowed to use gyro.
But the robot says that there is gyro here. You see?
Yes, the robot says there is gyro, but maybe the same program, this task, you're not allowed to use gyro.
Maybe.
Even though it's a task, maybe you're not allowed to use.
Yeah, maybe yes. Anyway, you got the idea now, right?
Yes.
So I want you to explore today until we meet back tomorrow. I want you to explore today how to perform one of the missions. Okay?
Okay. Where you can find the missions?
These are the missions. You try to make yourself missions. Like we made ourselves a mission to put the car in the parking lot, right? We took this green car to this red parking lot.
When I play tomorrow in the morning, I'll make a challenge that I will make the robot, he will park in his place.
Yeah, maybe.
Make him park there.
Yes. Okay, let me try something now. So do if. We took this one already. Let's use the logic. If, yes, you see now, is if the gyro angle, you see, it's gonna work. If the gyro angle is equal to, or we prefer to use greater than or equal to, I should use a number here.